first operation we're going to take a look at is called matrix addition. And when two matrices have the same size, then we can add them together. And the idea is to add the corresponding entries together. Now down here at the bottom, I've wrote out mathematically what it looks like to add two matrices together. And when we're talking about matrix operations, we're going to use the notation ij. So if I'd like to know what this means in English, essentially this part here means the entry in row I and column j of the matrix capital A. And when we fill in the other two in a similar way, we have that this represents the entry in row I, column j of the matrix capital B, and on the right we have the entry in row I, column j of the matrix A plus B. What this expression is saying is if we see two matrices side by side, in order to add them, as long as they have the same size, we're going to take the entry in row I, column j of A, and add it to the entry in row I, column j of B. So let's say we're given the two matrices, capital A and capital B, and we would like to add them together. The first thing we have to do is check the sizes of our matrices. What is the size of matrix A? Well, matrix A has 3 rows and 2 columns, so we would call it a 3 by 2 matrix. And same with B. B has 3 rows and 2 columns, so it's also a 3 by 2 matrix. Since these matrices are the same size, we're going to be able to add them together. So the matrix A plus B will look like this. We're going to take the number in the 1, 1 entry of A, and we're going to add it to the number in the 1, 1 entry of B. 2 plus 1 gives us 3. Next, if we move over to the entry in row 1, column 2, we would get negative 3 plus negative 1, or negative 3 minus 1. And that would be negative 4. And we can go ahead and do this entry by entry. Our next entry would be 1 plus 0 for 1, 0 plus 2 for 2, and so on and so on. So we'd have negative 2 minus 1 is negative 3, and finally 5 and 4 would give us 9. So this would be the matrix A plus B. So let's try to do one more example. Here we're going to take a look at A, and A is a 2 by 2 matrix. It has 2 rows and 2 columns. B has 2 rows and 1 column. And when we go to add these together, we note that we do not have the same size matrix. So it's going to be impossible for us to find the matrix A plus B. In fact, we usually say that the matrix A plus B is undefined. And the reason is A and B are not the same size. The next operation that I'm going to show you a couple examples of is called scalar multiplication. And unlike matrix addition, matrix scalar multiplication is always defined. We don't have to worry about sizes of the matrices that we're going to be multiplying into. If we would like to scalar multiply a matrix, the idea is we take every entry of the matrix and we multiply by the scalar number. Here I'm representing the scalar number as k. And once more, this expression here represents the entry in row I, column j of matrix capital A. And here's the relationship between the two expressions here at the bottom. Over on the left-hand side, we have the entry in row I, column j of matrix A multiplied by the scalar number k. And that is equal to the entry in row I, column j of the matrix k times A. So if we have this matrix A, let's go ahead and calculate 5 A's. Well, what we do in order to scalar multiply is we take all of these values up here inside our matrix and we multiply by this particular value. So 5A would give us the new matrix 10 minus 15 5. And in row 2, we'd have 20, 0, and minus 5. We could also do the multiplication minus 2 times A, and that would give us the new matrix that would look like this. Minus 4, 6, minus 2, minus 8, 0, and 2. So remember, when you're scalar multiplying, all we do is we take our original matrix and we multiply all of those values by whatever scalar number we see out front. Now, to close off this video, I just have a couple questions that you may have thought about as we were working through the previous couple of slides. And the first question is, why in the world do we define matrix addition and scalar multiplication like this? And to you, I would say, because I said so. No, I'm just kidding. But it turns out that if we do define addition and scalar multiplication this way, then there are a lot of nice properties that are satisfied. And we're going to take a look at some of those properties in class. And this kind of ties into the second part as well. By defining the addition and scalar multiplication in a specific way, then we set up certain groups of matrices to be called vector spaces. And that's something that we would study in linear algebra part 2. All right, my little epsilons, stay positive.